Okay, good afternoon, all of you. Am I audible?
Yes, sir.
Why today's strength is very less? Hmm? Can anybody put the message? All of you put the message on your group. So we conduct the lecture. Okay. Okay. What about my screen? It is visible, all of you.
Yes, sir.
Okay. So now in the last lecture we have started the biasing, right? So in that we have seen self bias. This point we have covered, right?
Yes, sir.
Today we have to see the JFET as an amplifier. Okay, so that much difference is not in JFET and BZT. Okay, so just for the junction effect. Okay, so here JFET as are used commonly used for the amplifier as a small signal, right? So or small AC signal. So okay, one of the reason for JFET instead of bipolar junction transistor is that very high input impedance. What is the difference? Why we have going for the JFET as amplifier instead of BZT? At that point, it's a very high input impedance, that is ZI. So that's why we obtained for JFET as a amplifier. Now got it point? Why we have go for this? आपल्याकडे BJT होता तर JFET म्हणून कशाला वापरतो आपण amplifier? So one of the advantages is that very high input impedance. That's why we move toward the JFET as an amplifier, right? So we can obtain it. The big advantages, or sorry, big disadvantages, however, is that the voltage gain, that is AV, obtained with JFET is very small. This is the big disadvantages of JF. Okay, this is disadvantages or advantages? काय आहे बरं? व्होल्टेज गेन कमी आहे म्हणजे ऍडव्हान्टेजेस आहे का डिसएडव्हान्टेजेस आहे? Am I audible to all guys?
Disadvantage.
Yes, sir.
Okay. So whenever we are going to design any circuit, we want high gain, right? So आपल्याला बघा आपण जर एखादा if we use any circuitry, or if we use a simple example as a charger, mobile charger, if we give as a 230 volt as the input, so we want at least our whatever we have requirement, right? If below that, that is not used for us, right? So that time this is a disadvantage. Okay, now the big disadvantages of JFET is a voltage gain, right? And what is the advantages over a bipolar junction transistor? The input impedance is very high. Okay, so now we see the different configuration. JFET amplifier configuration, that is common source, common gate, and common drain, right? So in a BZT, what is the name of that? Common collector, common base, common emitter, right? So similar. Now see, this is the common source. Where is the source terminal here? कोण सांगेल? ओके, काय चेंज केलं बरं? हे मला वाटतं ट्रान्झिस्टर वापरला का आहे? Is it a transistor or UZT? Sorry, JFET. Yes. What is this?
JFET.
Okay, so where is the source? Is the common, right? Source here. This is they separately indicated here, but the source is the common to all. हे जे ground दिसतंय का सगळ्यांचं केलेलं बघा separate.
Sir, first
yes.
side is visible.
Okay, thank you. काय तुम्ही लोक काय सांगत नाही राव, काय दिसतंय काय नाही. Now it is visible circuit diagram to all guys?
Yes, sir.
Yes, sir.
Okay. Please notify if I move the slide but you are not visible, then let me know. Because when I move to the next slide, I can see that slide, but you are unable to see. But how I can know ki you are not visible to that screen? So that's why give the intimation if it is not visible. Okay, guys, henceforth. ओके, कुण्याही याचा शेवट गोड असावा. माहित आहे ना तुम्हाला, म्हण माहित आहे का?
Yes, sir.
तर तुम्हाला शेवट गोड करायचा आहे का का नाही? मला असं आवर्जून वाटावं का मला बी डिव्हिजन शिकवायला द्या म्हणायला. मी जाऊन मागायला हवं तुमचं डिव्हिजन, जर तुम्ही शेवट गोड केला तर. एक सेमिस्टर चांगला राहिलात आणि शेवटी जर असं करू लागलात तर कसं होईल? मला खरंच वाटेल का तुम्हाला पुन्हा शिकायला तुम्हाला शिकवायला आवडेल का? कारण तुम्ही सेमिस्टरभर छान रिप्लाय दिलात. आता शेवटी 2 लेक्चरसाठी तुम्ही असं काय करताय मला काही कळत नाही लोक. ओके, सी नाव हिअर the source terminal is making here as a common to this circuit, right? So now when they apply the input, what is the output? Output कसं यायला बरं? फेज रिव्हर्सर येतोय. आउटपुट कुठला आहे यामध्ये? ओके, सी this is the source. My spotlight is visible to all guys.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, see, this is the common source, right? The source terminal, this is the source terminal. We make this is a common to all. Here I indicate separately as a ground. Means we can make this, all these are the common and make it as a ground, right? समजतंय काय म्हणतोय ते?
Yes, sir.
Okay, so see, this is the waveform. What we apply here as a input is a VGS cube, right? VGS means gate and source terminal is apply as a input terminal, right? And output is taken from source and
Drain.
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 Very good, drain. So see, this is the input waveform is given to the circuit. So if we compare the output, it is amplified or not?
Yes, sir. Amplified.
Yes, sir.
But the phase is shifted
Shifted.
by 180 degree.
180 degree.
Right. So same, any difference is there in the amplifier of the BJT amplifier as an and JFET amplifier?
No, sir. Same.
No, same. Just the advantages is here the input impedance is very
High.
high, and disadvantages of JFET is
Voltage gain is low.
voltage gain is low, right?
It is
So
also
and remaining part is similar to the BJT, right? Here C11 is there, here also C, common emitter, आणि आपण कपलिंग कॅपॅसिटर वापरला, बायपास कॅपॅसिटर वापरला, हे सेम आहे. बाकी सगळं वर्किंग. काही कंपोनंट चेंजेस आहेत का? फक्त ओनली चेंजेस इज दॅट व्हॉट इज द चेंज? Instead of BJT we are using here as a JFET. Okay, so here I hope here there is no need to explain in detail theory, or is it?
Yes, sir.
Is it required to explain it again?
No,
No,
sir.
sir.
No, sir.
Okay, thank you. So we move towards next point. Okay, so now what is visible to all guys?
Common source amplifier.
Circuit diagram or some theory?
Theory.
Theory.
Okay, now here I have given the theory related to that. So bias voltage, what is the drop across the bypass capacitor, or all that theory related to I have written here. Okay, so when you taking or when you are making a notes at that time, use this theory, okay, or use this key point for your explanation. So what is here? If only the change here has Q point value is the varying between the drain to source voltage, right? And the phase shift is 180 degree. We have seen just. Okay, so the changes is that instead of whatever the source across the drop resistor, bypass capacitor, the notation is notation is different, right? There we use as a CC1, CE1, right? So remember that modification, whatever is the made here, and the whole or the theory is related to that is the same. What is the function of drain, what is the function of source, what is the function of gate, is you all are aware related to that. So shall I explain here or shall I move ahead? Otherwise we go for this in short, the biasing voltage produced by the drop across source resistor, that is RES. Okay, so the bypass capacitor here is used as a C2, right? By keeping the source of FET effectively at a ground level. काय या वाक्याचा मिनिंग कळतोय का काय आहे ते? हे बघा, सोर्स काय केला इथे? Keeping as a ground, right? So that's the meaning of that sentence. Okay, so now the third point is the input signal voltage causes the gate to source voltage. Gate to source म्हणजे gate to source काय केला आहे? It is the common source, right? So source terminal we make as a common. So that's why they use as a this sentence. Okay, now and the Q swap above the value between the Q point, that is VGS. What is the VGS? Voltage across gate and source, and the Q point ICQ, VCEQ, right? आठवते का तुम्हाला?
Yes, sir. Yes, sir.
So there in the VCEQ instead of VCEQ, what here write is as a
VGSQ.
VGSQ, right? Remember that notation. Don't confuse in between them. Okay. Now, fourth point, as the drain current increases, the voltage drop across RD. म्हणजेच कुठला रजिस्टर आहे तो?
Drain resistor.
Drain register decreases, right? Now, the drain current swap above and below its a Q point, the value in phase with the gate to source voltage. काय सांगितलं? The drain current vary झालाय, right? Drain current vary झाला तर व्हॅल्यू काय येते? Q पॉइंट कुठे ड्रेन करंट जर व्हॅरी केला तर Q पॉइंट व्हॅरी होतो कुठे? खाली किंवा वर. त्याचा इफेक्ट काय होतो? तो इन फेज विथ गेट अँड सोर्स व्होल्टेजच्या इन फेज असणार, राईट? गॉट इट नाव?
Yes, sir.
Yes, sir.
Okay, then last point is the same. The phase shift between them is a 180 degree, right? Now we move toward the some external notation what they are mentioned here. You can see that. Now another point, that is the common drain. This is circuit for the common काय केला इथे?
Drain.
Right? So I think no need to go in detail explain that. You all are aware related to that, how to make as a common drain and how to make as a common source and how to make as a common gate. समजलंय? जे आपण कॉमन इमिटर, कॉमन बेस, कॉमन कलेक्टरच्या डायग्राम बघितल्या होत्या, it is similar to the that diagram, but just we have to, what we have to replace there? You have to replace
Notations.
notation and JFET instead of
Transistor.
transistor. Okay, and the remaining part is the same. Up till this now, anyone has any doubt?
No, sir.
JFET मध्ये कोणाला डाऊट आहे का? असेल तर विचारा. Otherwise we move towards the MOSFET. सिक्स्थ युनिट मध्ये काय शिकताय फक्त तुम्ही? दोन कंपोनंट. कुठले कुठले?
JFET and MOSFET.
MOSFET, and only introductory part, not in detail. So the unit of 6 unit is very small. Okay. Now we move toward the metal oxide semiconductor, that is the MOSFET and its characteristics. So the name indicates metal oxide semiconductor, and the remaining part is field effect transistor, right? only 3 word is added: metal oxide semiconductor. Right? इथे काय केलंय त्यांनी? कुठला मटेरियल वापरला?
Metal oxide.
Okay. So what is the advantages of that? Can anybody guess?
High voltage and current gain.
Right. किंवा त्याला एन्व्हायरमेंट जो इफेक्ट आहेत, अटमॉस्फेरिक इफेक्ट, it is a
Temperature effect is decreased.
right. Very good. Avishkar, you want to say something or you want to add something?
No, sir. I guess as here metal oxide na, so I guess only the that protect from corrosion like
Right.
that.
Yeah, that comes under the environmental effect.
Yes, sir. Yes, sir.
Okay. Very good.
Reactional effect is also decreased.
Yeah. Reactance also decreases. आणखी काय वाटतंय बरं? Guys,
Quick response.
okay, response मध्ये चेंज होतो. Okay, so I think this is Shubham, right? MOSFET is used in mobile processor. Good. Yes, application, that is application. Okay, now see, we see the in detail part. Sharyu, are you there? Sharyu?
Yes, sir.
Are you fine?
Yes, sir.
So why you are not going or why you are not studying anything? Do
Yes,
it,
sir. I
don't.
told my best.
Okay, try it first. Okay, now, so in a metal oxide semiconductor field, it is a part or it is a type of FET. Okay, so here also gate, source, and drain is just like the say FET. Metal oxide, it is a subtype of FET, right? Now their drain current of the MOSFET is controlled by gate and source voltage. That is nothing difference. Okay, so there are 2 basic types of MOSFET. That is, first one is
Depletion,
deflection and
enhancement.
enhancement. Good. There is a 2 part type. Okay, so enhancement type of MOSFET is usually referred to the called as a E-MOSFET. It is also called as E-MOSFET. That is a enhancement MOSFET. And deflection type of MOSFET, it is also called as a D-MOSFET. Right? So the another one word for the ZF MOSFET is used to, or it is referred as a IGFET, because the gate is insulated from the channel. Insulated म्हणजे काय?
Silicon dioxide layer is present there.
Right. So when you observe the capacitor, in that one dielectric material is added, right?
Yes, sir. Work like capacitor.
So yeah. So same material here added in the gate, instead in the gate. Okay, so that's why, see, this is the structure. Now this is the structure of deflection type MOSFET. So here one substrate is added, right? कुठला बघा या गेट मध्ये, ड्रेन सोर्स मध्ये त्यांच्यामध्ये एक तुम्हाला मेटल ऑक्साइड त्यांनी हे केलाय, मेटल कॉन्टॅक्ट अवॉइड करण्यासाठी टाकले, दिसतंय का यात?
Yes, sir.
Okay, so this is the symbol of MOSFET. See, one more substrate is added here, right? So the drain and source is connected to the n-doped region, and the n-doped region are connected via n channel, right? So this n channel is connected to the gate via thin insulating layer. Thin insulating layer, that is the silicon dioxide. So the indication of SiO2. माहित आहे ना, केमिकल नेम ऑफ, और काय म्हणतो आपण याला, कुठलं नाव म्हणतो याला?
Silicon dioxide SiO2. Yes, sir.
Yeah, SiO2 means indication. What is the name of that? ओके, वॉटरला काय इंडिकेशन आहे?
H2O.
H2O. काय आहे ते नाव? कसं आहे H2O? म्हणजे कुठलं नाव म्हणतो त्याला आपण?
Chemical formula.
Chemical formula. So that's the here the silicon dioxide is the chemical formula of metallic.
Silicon dioxide.
Right. So here the use. Okay, now you are confused little bit, so some chemistry is also included in this electronics. Don't be go in that. Okay, now you got the application of chemistry where you have used in the 12th standard. You studied chemistry, physics, something else. At that time you think where we are using this, right? Why we are studying this? There is no use of that chemistry and physics, right? Now you are thinking when I studied M1, M2, M3, so but where is the use of that, right? असा क्वेश्चन पडत असेल ना तुम्हाला. आपण
Yes,
M2, M3 शिकतोय, कुठे वापरतोय आपण, हे कशाला लागतंय असं वाटत असेल ना तुम्हाला.
yes, sir.
जसं तुम्हाला आता 12वीला असताना केमिस्ट्री कशाला शिकतोय असं वाटलं असेल. नाव यू गॉट द application where we have using the chemistry, that block diagram or block table, D block, F block, right? Have you studied that?
Yes, sir.
One which block? That F block, I think. F या B block. Li, SE, that is one table, right? Latur se Para Nanded. Have you remember that hint in a block diagram? Block table, chemistry, that table. आहे का कोणाला माहिती आहे का त्याच्यात अटॉमिक नंबर किती येतो, आपण असं लक्षात ठेवायचं बघा. I don't know you are remember or not, but I remember that hint. So when I give the exam of related to the CET, at that time in my syllabus there is a one chapter for especially for F block. I think I didn't read D or F. I confused that. So in that one block is there lithium, ion, oxide. So you have to remember that atomic number. Suppose if I ask the carbon, what is the atomic number of carbon?
Carbon has 3 isotopes, sir, 14, 15, and 16.
Yeah. So the generally we are using as a 14, right? Generally. So at that time you have to remember. So it is very difficult, right? So, but when I studied for the when I studied for the CET exam, at that time I made one hint for that block, Latur se Li, Se, Latur se Para, PR, right? Like that. I made that hint. Okay, if anybody want, then I will explain all that thing, but later. Now, got the application where we are using here chemistry, right? Okay, so now the N channel is connected between them and construction of substrate or all other things are added here for the insulating type. So, okay, so see, this is the diagram. So substrate as here added here SS, right? So that SS is connected with the gate or with the source. Source सोबत आपण काय केला तो एक connect केला आहे. This is the construction diagram of deflection type of MOSFET. Okay, now this is the symbolic representation. बघा P channel, N channel दिसतंय. Substrate कुठे दिसायला तुम्हाला यामध्ये? This is substrate material.
Yes, sir.
Okay, now in a second diagram you are confusing why they are, sorry, P channel and N channel only 2 and why you are writing as a 3 symbol or 4th symbol, right? So this symbol is like this. This is S is connected with SS. SS means substrate and single S is source. Okay, so we are at connected that. So that's why I mentioned here figure number B and figure number A. Okay, the different representation is there. So if sometimes they give like this symbol and sometimes they give like this symbol, so don't be confused a little bit. So that's why I put here as a 2 different symbol. Okay, now the deflection mode characteristics. Here, if you observe the characteristics of FET, or sorry, JFET, so where any modification is there? Where it is modification? Can anybody? बघा कुठपर्यंत सारखंच आहे, JFET सारखंच आहे का डिफ्लेक्शन रेंज मॉस्फेटच्या कॅरेक्टरिस्टिक्स? जोपर्यंत VGS इज इक्वल टू 0 आहे तोपर्यंत बाकी कॅरेक्टर सिमिलर आहेत का? बघा VGS 0 आहे तिथपर्यंत हे कॅरेक्टर सेम आहेत, FET सारखेच, JFET सारखे. मॉस्फेटचे कॅरेक्टरिस्टिक्स आहेत का सेम? येस और नो?
Yes, sir.
बघा इथपर्यंत बघा, इट इज सिमिलर टू द when VGS is equal to 0 up to that point the JFET and deflection MOSFET, it is a similar characteristics. Now where is the changes here? The changes is that when VGS is greater than 0 and ID no
Less than.
नाही it's here, don't go for this. बघा आता लेस दॅन 0 म्हणल्यावर काय यायले?
-1, -2,
Right.
-3.
So at that time it is similar to the JFET. JFET चे ते कॅरेक्टर सिमिलर आहेत का? हे JFET चे कॅरेक्टरिस्टिक्स आहेत. पण बियॉन्ड और ग्रेटर दॅन VGS, जेव्हा VGS हा 0 पेक्षा जास्त होतो, there is the part comes for the MOSFET, that is enhancement or deflection MOSFET. Up to the VGS is equal to 0, up to the 0 level, the character is same, is like a JFET. मला काय म्हणायचं समजलं का तुम्हाला? जोपर्यंत VGS is equal to 0 आहे होईल तोपर्यंत डिफ्लेक्शन लेयर किंवा मॉस्फेट, इनहान्स मॉस्फेट किंवा डिफ्लेक्शन मॉस्फेट सेम कॅरेक्टरिस्टिक्स आहेत ऍज अ JFET सारखे. बरोबर आहे? समजते का मी काय म्हणतोय ते? जेव्हा 0 ला क्रॉस करेल, वर जाईल पॉझिटिव्ह मध्ये, that time parts comes for the FET and MOSFET. MOSFET चा पार्ट केव्हा येतोय? ओके
When VGS is greater than 0.
ओके. आपण ऍडव्हान्टेजेस काय सांगितलं होतं बरं? इट इज प्रोटेक्टेड फ्रॉम environmental
Effect.
effect. It may be temperature, it may be humidity, it may be something else, corrosion or all that, right? मग ते कधी जेव्हा हाय टेम्परेचर झालं किंवा हाय व्होल्टेज दिलं त्यावेळेस त्यांना ते प्रोटेक्ट केलं पाहिजे. बरोबर आहे? सो दॅट्स वाय हिअर एज इंडिकेटेड हिअर ऍज अ वेन. बघा इथपर्यंत तर सिमिलर आहे FET टाईप सारखा. तर चेंजेस कुठे व्हायलेत? कुठे व्हायले चेंजेस? जेव्हा VGS 0 ला क्रॉस करेल. बरोबर आहे? कन्फ्यूज होत आहे का? कन्फ्यूज होत आहे तर इथे बघा. आर यू गेटिंग और नॉट गाइज?
Yes, sir.
इफ यू आर नॉट गेटिंग देन लेट मी नो. बघा या डायग्राम मध्ये काय दाखवलं, इथपर्यंत तर कॅरेक्टरिस्टिक सेम आहेत का आपल्या JFET सारखे आहेत का? 0च्या वरचं सोडून द्या, तोपर्यंत हा ब्लॉक वरचा सोडून द्या, तिथपर्यंत सांगा मला. हे ना इथल्या एवढ्या मोड सोडून द्या तुम्ही, हे बघूच नका वरच्या. हे खालचा जो पार्ट आहे हा मॉस्फेट सारखे आहेत का? सॉरी JFET सारखे कॅरेक्टरिस्टिक्स आहेत का सेम ऍज अ JFET?
Yes, sir.
Okay, now the only remaining part is that the difference is the above VGS च्या 0 पेक्षा वर व्हॅल्यू घेतली, VGS च्या 0 पेक्षा वर व्हॅल्यू घेतली तर तो कुठे चाललाय आपला? MOSFET म्हणून ऍक्ट होईल, राईट? सी हिअर दिस कंडिशन, VGS is greater than 0 it increase the IDS. For this, the formula is to plot the transfer curve. What is the formula for that? This formula. The कुठलं इक्वेशन म्हणत होतो आपण? शॉकी, राईट? कुठलं इक्वेशन होतं पॉइंट सिलेबस मध्ये?
शॉकी इक्वेशन.
राईट. ओके, इथपर्यंत क्लिअर आहे?
येस.
आता बघा, इन्हान्समेंट टाइप मध्ये मॉस्फेट मध्ये आणि डिफ्लेक्शन टाइप मॉस्फेट मध्ये तुम्हाला काय डिफरन्स वाटला? आता ही डायग्राम बघा. टेक अ स्क्रीनशॉट ऑफ दिस गाइज. टेक अ स्क्रीनशॉट ऑफ दिस and tell me the difference between them and this. हे एक बघा, घेतलाय? काय काय वाटलं तुम्हाला चेंज? काय वाटतोय? आहे का नाही बरं काय चेंजेस?
Yes, sir. There is change.
Then who is going to notify that if anybody has noticed?
Can I?
Still.
There is one more n channel between that two n channels, like column n channel.
Very good. Very good. Very good. Now बघा, आता तुम्ही जरा सिम्बॉल मध्ये बघा, तुम्हाला लक्षात येईल काय केलंय इथे सिम्बॉल मध्ये. सिम्बॉल बघितलंय?
Yes, sir.
आणखी याचा सिम्बॉल बघा. चला, काय वाटला बरं चेंजेस तुम्हाला याच्यावरून तरी? काय
There is a cut.
right. So each and every region has separated by their metallic or enhanced type material added, right? So each and every material has a separated. समजते का बघा इथे केलंय का? So here right. समजते का इथे चॅनल काय केलंय? Now the remaining part of N channel and P channel we see in a next lecture, and only after only one or two lecture is required for to complete the unit number 6. इथपर्यंत कुणाला काय डाऊट असेल तर विचारा, otherwise we stop here. Okay, so anybody has any doubt?
No, sir.
असेल तर विचारा, आपण बघू. Everyone put the message in chat box. Okay, so I hope you all have put the message. So we stop here. Thank you so much. Have a nice day.